All right, question 28. At noon, ship A is 100 kilometers west of ship B. Ship A is sailing south at 35 kilometers an hour, and ship B is sailing north at 25 kilometers an hour. How fast is the distance between the ships changing at 4 p.m.? So the first thing we're going to do is we're going to write diagram. So we're going to make this ship A, and we'll make this one over here ship B. We're going to call this value x. Now we know that x is equal to 100 kilometers, because that's a given. Then ship A is sailing south at 35 kilometers an hour. And so I'm going to label this C, and so we're going to call this d of C over dt of dt is equal to 35 kilometers an hour. Then we're going to go over here, and ship B is sailing north at 25 kilometers an hour. So it'll be 25 kilometers an hour, and I'm going to call this one Z. So D in respect, or D of Z in respect to T is equal to 25 kilometers an hour. And I'm going to label this whole thing Y. So, which means the derivative of Y in respect to T is equal to derivative of C in respect to T plus the derivative of Z in respect to T as well. And we solve that just by doing some substitution. It's equal to 60. So our derivative of Y in respect to T is equal to 60 kilometers an hour. And I'm going to go ahead and draw another diagram whenever this is at 4 p.m. Since this one's at 12, this one will be at 4, and we'll have actual values here. So like this. All right, so since our d of z is equal to 25 kilometers an hour, and we're going 4 hours away, we're just going to go ahead and multiply that by 4h. And so this will give us our z, which is equal to 100 kilometers. So we write that in here, 100 kilometers. And this is where B is now. And this is still 100 kilometers over here. Next thing we're going to do is find what our C value is. Derivative of C in respect to T is 35 kilometers an hour. And since we're going 4 hours still, just multiply that by 4h. And we get C is equal to 140 kilometers. So we got that right here. So since Y is equal to C plus Z, which is equal to 100 plus 140, Y is equal to 240. Or let me just go ahead and write 240 there. And here's A. So I'm going to go ahead and draw a right triangle with this. It looks about like that. Where Y is our height, our X value is the width, and then this hypotenuse is going to be our H. Just label that right there. So with Pythagorean Theorem, we know x squared plus y squared is equal to h squared with a right triangle. And we know what our x value and our y value is. So we're going to go ahead and plug those in. So we have our 100 squared plus 240 squared is equal to h squared. And 100 squared plus 240 squared is 67,600. And if you take the square root of that, let me plug that into the calculator real quick. 260. All right. And we're looking for the derivative of h in respect to t. And to get that, we're going to take the derivative of the Pythagorean theorem in respect to t. And that'll give us 2x d of x in respect to t plus 2y d of y in respect to t, 2h d of h in respect to t, and we're going to cross out all of those 2's. And since we're solving for d of h, we're just going to go ahead and use the wall and divide by h, which will get rid of it over here, and put all of this over h. Now all we have to do is plug everything in. So we have 100, and d of x, d of t is 0 because that's a fixed value. Then we have that plus 240. And then our d of y in respect to t is 60. And our h is 260. And we have that equal to d of h, derivative of h in respect to t. And then all we do is plug that into the calculator, get our answer of 55.385. So that's going to be our answer. Then the next thing we could do is find the units, and then we just plug our units into the same formula. So we have x is kilometers, d of x is going to be kilometers an hour, and it doesn't matter that the value is 0, it's still going to be kilometers an hour. Same thing for y, it's kilometers multiplied by kilometers an hour. And everything is over h, which is also a value in kilometers. So in the end, these will just cross out, and you're left with the derivative of h in respect to t is equal to 55.385 kilometers an hour.